You no know me, you for Google. I say this head bigger than your dugu. Stubborn academy, we like to shoot too. One bullet, I say chale, it go make you poo poo. On a bicycle, so take your trailer and I'll be famous like Mali.
Alright, welcome everyone. So today we are going to be looking at the Gauss's law. So we also solve a question concerning the Gauss's law. So we have that the Gauss's law talks about the electric flux. So this represents the electric flux, and it's saying that the electric flux in a closed surface is equal to the net charge all over the permittivity of free space. So if we divide the net charge with the permittivity of free space, we are going to get the electric flux. So that is what the Gauss's law is saying. So now, if you watch this, we can use this to illustrate this Gauss's law. We have a closed surface, and this closed surface is what we call the Gaussian surface. So if we look here, we see different charges. So we have charge Q0, Q1, Q2, Q3, and Q4. Now, from the law, what are the net charge? The net charge are the ones that pass through the closed loop. So that means Q1, Q2, Q3 is what will correspond to the net charge. Meanwhile, Q0 and Q4 won't be part of the net charge because the flux here, the Q0 and the Q4 are not passing through the loop. So that is why we don't include Q0 and Q4. So that means the net charge through the closed loop will be Q1 plus Q2 plus Q3. So that gives us the net charge. Now, when we talk about the electric flux, we are talking about the electric field lines that pass through an area. So that gives us the electric flux. So E represents the electric field and A is the area. Then we have the angle, which is cos theta. So theta here represents the angle between the field and the area. So now from the question here, we have that calculates the electric flux for the surface below. So this is the surface that we have, and we want to calculate the electric flux. So from our formula, we see that the electric flux is equal to EA cos theta. So where we are given the electric field, which is 350 Newton per coulomb, and we can also find the area. The area is calculated from the shape, which is area of a rectangle. So that means the area will be equal to the sides and the length, which is 20 times 15. So 20 times 15, if you multiply, this will give us 300. So we have 300 centimeter squared. Now, we know the E is given as 350 Newton per coulomb. So the Newton is in the SI unit. So that means the centimeter should also be in In SI unit. So that means we convert centimeter to meter. So if we want to convert, what we are going to do is we multiply 10 raised to power minus 4, and it will be in meter squared. So that's how we do the conversion. So we can now go straight to substitute. Here you can see the angle. So our theta is also given as 50. So if we substitute, we'll be having E, rather your phi, is equal to E, which is 350 times A, which is 300 times 10 raised to the power minus 4 times cos 50. So if we punch this in the calculator, this will give us 6.75 as the answer. So that's how we get the electric flux passing through the area. So which the unit is in Newton meter squared per coulomb. So that is the electric flux. So thank you. In the next video, we'll see and the capacitors and how we can do calculations with capacitors.